Okay, welcome everyone to my new YouTube channel. So this is going to be the first Math 136 lecture online. Today I'm going to be talking about infinite sums, in particular geometric series. So this is like the 8th time I tried to do this, so I hope it works this time, otherwise I might just give up. So let me just briefly recall. So this is chapter 9.2 in the textbook. So let me recall briefly finite sums and infinite sums. So these are basically the two different kinds of sums that there are. So finite sums are basically what you think of when you think of sums. You just add together finitely many numbers. So we could often, the notation we use for this is the sigma notation. So we would take the sum from I equals 0 to n of ai for some real numbers ai. So an example of this is like 1 plus 2 plus 1 over 3 plus pi. This is a finite sum. An infinite sum is a limit of finite sums, or partial sums if you want. Finite sums or partial sums. So we denote it like this: the sum from I equals 0 to infinity of bi for some coefficients, for some real numbers bi. I mean, you could use any letter, but basically the sigma notation is the thing that will always appear in common. So the meaning of this is the limit as n goes to infinity of the sum from I equals 0 to n of bi. So this right here is is what we call the partial sum. So I think in the textbook they denote it by Sn. So if this limit converges, then we say this series converges and its limit, or it's equal to whatever this limit is. So let me give an example of an infinite sum. So 1 over 3 we know has the decimal expansion 0.333, etc. Where the 3 goes on, 3's go on forever. Now this we can write, so I want to write this using this notation, so you can check that this is equal to this. The sum from I equals 0 to infinity of 3 over 10 times 1 over 10 to the power of I. If this isn't clear to you, you should take this and actually start writing out the first two terms. So write out the 0th term, the I equals 1 term, the I equals 2 term, and you should see that this is equal to this. They're the same thing. So we are saying that this series, this sum, the infinite sum exists, or converges, and it's equal to 1 over 3, or 0.3333, etc. Now this, in particular, is an example of a geometric series. So let me erase this right here. So a geometric series is a series which has the following form: I equals 0 to infinity of a times s to the I, where a is a constant. Now here we need, in order for this to converge, we need the absolute value of x to be less than 1, and if so, it's equal to a over 1 minus x. So if the absolute value of x is less than 1. If the absolute value of x is not less than 1, then the series diverges. So it's very important that the absolute value of x is here is less than 1. Now this, so you should take 10 seconds and think about how this is a geometric series. So what is the a here and what is the x here? So I'll give you 10 seconds and I'll just blurt it out. Dun, dun, dun. Okay. So right here, the a is 3 over 10, and the x is 1 over 10. So certainly 1 over 10 has absolute value less than 1, so everything is good. And you could use this formula to actually compute this. So even if you didn't know what this was equal to, a priori, you could use this formula, to compute that this is actually equal to 1 over 3. So now let's do that. So using the formula, we get that this is equal to 3 over 10 over 1 minus 1 over 10. Now this is equal, now I don't want to go forward, so this is equal to 3 over 10 divided by 9 over 10. The 10's cancel, so this is 3 over 9, which is equal to 1 over 3. So it works. So now I just want to maybe give a brief explanation of where the formula comes from. So this is going to take a bit of magic. So I'm going to write it. I'll write something out. You're not going to know where it comes from, but the point is that it explains the formula at least, or it proves it. So if we take 1 minus x and we multiply by 1 plus x squared plus dot 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 plus x to the n, we get 1 minus x to the n plus 1. So it might not be obvious to you that this is true, but if you should actually take this, so if you want to pause the video and expand it out. So multiply 1 by each term, multiply x by each term, and then subtract it. Subtract them. And what you're going to get is this. Now this thing right here is equal to the sum from I equals 0 to n of x to the I. So if 1 minus x is not, if x is not equal to 1, we could divide both sides by 1 minus x, and we get the sum from I equals 0 to n of x to the I is equal to 1 minus x to the n plus 1 over 1 minus x, as long as x is not equal to 1. Now, we want to take the limit of this as n goes to infinity to get the special case of this formula where a is equal to 1. Now, in order to do this, if we look at the right side, we see that we need x to the n plus 1 to converge as n goes to infinity. Now, x to the n plus 1 will only converge if the absolute value of x is less than 1. So, the limit as n goes to infinity of x to the n plus 1 is equal to 0 if the absolute value of x is less than 1. If the absolute value of x is bigger than 1, then x to the n plus 1 will diverge as n goes to infinity. If x is equal to 1, then this expression isn't even defined, but you could check that the infinite sum will diverge if x is equal to 1. So what we get is, now let's take the limit as n goes to infinity, we get this. 1 over, so this is equal to 1 over 1 minus x. So this is the special case of this formula where a is equal to 1. Now if we want the more general case, all we have to do is multiply both sides by a. So multiply both sides by a, and you get a times this infinite sum is equal to a over 1 minus x. Now we could use the distribution rules of multiplication, and we could bring this inside the sum, multiply each term by a, so this is the same as this. And this gives this formula. So hopefully that wasn't too bad. I'm going to look at the video and this will improve the time. If you want, you could comment any suggestions, and anyways, thank you for listening.